Right, today we have a problem where two integers are randomly selected, and we want to know what is the probability. Let's let A be the first one, the first randomly selected integer, and let's let B be the next one. Another way of stating what we're seeking here is that A cubed plus B cubed would be congruent to 0 mod 7. Again, mod is just an abbreviation for modulo. Okay. Again, another way of stating this would be A cubed plus B cubed is just 7m for some m. Okay. And some people like to put uniformly here because that means any two integers have any single integer has the same likelihood of being selected as any other integer. Okay. Now, an important guiding fact in the way we're going to solve this problem is that the cube of any integer is congruent to just 0, 1, or 6. Y'all, what does this mean? It means that if you take the cube of any integer, it's going to either have a remainder of 0, which means it would be a multiple of 7, a remainder of 1, or a remainder of 6. So that's pretty sparse if you consider the fact that there's 7 possible remainders. A cube is any cube at all for any integer is congruent to either 0, 1, or 6. And I'll show you why real quick on that and then get down to why that's important. So 0 and 1 are obvious. Okay, so let's do 2 cubed. 2 cubes equal to 8. And I won't write down modulo 7, but that's congruent to 1, right? Okay, let's see here. 3 cubed is equal to 27. And that's certainly congruent to 6, since when you divide 27, let's see here, modulo 7, if you divide 27 by 7, you get a remainder of 6, right? Again, divide 27 by 7, you get 21 plus 6, right? Okay, so here we go. We got 1 and 6 consistent with what we've said so far. Now 4 cubed. 4 cubed is equal to 64. Now what happens when you divide 7 into 64? You get a remainder of 1. 9 times 7 is 63 plus 1, right? So this would be congruent to 1. All right, let's keep going here. 5 cubed. 5 cubed is equal to 125. What happens when you divide 7 into 125? Isn't 7 times 17 119? So you would have a remainder of 6 there also, right? A remainder of 6. 7 times 17 is 119, and plus 6 would be 125, right? All right, and so let's finally do 6. You'll notice we can stop at 6 because every integer is congruent to 0, 1, 2, 3, 4, 5, or 6. Okay, so we have 6 cubed. That's equal to 216. And that's pretty easy to see that that's congruent to 6 also, because 7 times 30 is 210. Okay, so that's congruent to 6. So y'all notice here, this is totally consistent, right? 0 cubed is congruent to 0, 1 cubed is congruent to 1. I left those out. But you see, all we had was 1, 6, 1, 6, 6, right? So this is true. We've proven this fact. Now, why is that important? Well, that means there's only 3 possible outcomes for a cubed number as far as what it's congruent to, modulo 7. Okay? And so that means there's 3 times 3 total outcomes as far as this, if you want to call it, experiment is concerned. So we'll write this down. The probability we're interested in, the total number of outcomes is certainly 3 times 3, right? There's 3 choices for the first number A, and there's 3 choices for the second integer B, right? 3 times 3, right? Those 3 possibilities are 0, 1, and 6, right? In other words, 0, 1, and 6 are the only possibilities mod 7 for an integer cubed. So 1, 2, 3, 3 choices for variable A, 3 choices for variable B, that gives you 9, okay? Now, how many desirable outcomes do we have here? Well, if you look at it from this particular point of view, you could only have 0 cubed, let's see, plus 0 cubed, right? okay, which that's congruent to 0, of course. Or you could have 6 cubed let's see here, not 6 cubed. Let me erase that. Hang on just a second. Okay, let's look at the two instances that you could have. You could either have um, 6 plus 1, or it's the first cube could be congruent to 6, and the second cube could be congruent to 1, and that would be congruent to 0 since it's equal to 7, right? Or the first cube could be congruent to 1, and the second could be congruent to 6, right? Now that's congruent to 0 also. And again, y'all, I'm talking about variable A and B here. Okay, as far as the letters I used up there. Variable A and B. And then, of course, both of them could be multiples of 7. Both of the cubes could be multiples of 7. Let me put congruent to 0 here and also congruent to 0. And I hope that I'm not leaving out too much here, but these are the only possibilities. Integer A cubed could be congruent to 6. Integer B cubed could be congruent to 1, right? Or the other way around. In either case, those sum up to 7, which is the same thing as 0 mod 7. Or they could both be 0. Other than that, you're not going to get anything to happen. In other words, 1 and 1 wouldn't work. 1 and 0 wouldn't work. 6 and 0 wouldn't work, right? So anyway, there's 3 outcomes here that are favorable. So you would get 3. And of course, the probability here is 1/3. Okay, so that's the answer we're looking for. You know, anybody who knows how to code, this is not a hard problem to simulate. That's it. I mean, the answer, the probability is 1/3. That's what I got at least. Let me know if I overlooked anything. But you could actually run a computer program to do this. You like do 100 iterations, generate 2 random numbers between 0 and, or just you could do it. The computer doesn't care. You could generate 2 random integers, right? Then find both of their cubes, sum them, and then check to see if it was 0 mod 7. Okay. And you should get something that approaches 1/3. Like you should get numbers in the range of 30, like 31, 32, 33, 34, 35 of them would be 1/3, you know, for 100. Now for 1,000, it would get closer and closer and closer. You know how it is, the theoretical versus the empirical probability, you know. But the answer I got is 1/3, folks, for this. And I don't think I made any mistakes. Let me know if you find anything wrong with that, okay? Or maybe you can think of a problem this problem is fairly rudimentary, not particularly challenging, but it just takes advantage of this fact right here, this guiding fact that any cube is 0, 1, or 6 mod 7. Okay, thanks for viewing.